problem right here. In this video I'm going to do the B part of this question, that is sketch the amplitude and phase spectra of phi of t is equal to phi of t for m of t is equal to triangular 100t minus 50. Okay, so this is the part we are going to deal with. In the A part I did in my previous video. If you want to see that, you can watch my previous video. In this part I'm going to deal with the B part. Okay, so here what is provided is m of t, that is equal to triangular 100t minus 50. Using this we can draw the picture of this. That's gonna look like this. It's a triangular and it's shifted 50 unit, but to look at the real shift I had to look at t, where's the t is shifted, so I had to divide both of them by 100. So this is 100t over 100, that is t, and then minus 50 over 100, that is going to be 50 over 100, that's half, 1 over 2. So it's going to be centered at 1 over 2, and its width is going to be, if we write t in terms of denominator, like if I want to get this as a denominator, then I have to put a 1 over 100 in the denominator, right? So then only I can have the t alone on the top. So that 1 over 100 is the width. So usually it's if it's width, if you don't have any shift, the width will be 1 over 100 this side, 1 over 100 this side. But since we have this one shifted here, the height is 1 because we don't have any amplitude here. So the height is going to be 1 right here, and then it's going to be 1 over 100 shifted to the left. 1 over 100, the width is going to be 1 over 100 to the left, and 1 over 100 to the right. And to find out what is the real value, then if you represent this one in terms of 50 over 100, then you can clearly see it. So if this is 50 over 100, then 1 over 100 this side, that's going to be 49 over 100, and 1 over 100 this side is 51 over 100. Okay, so like that, if you have the same denominator, it's easy to find what is the next value. So this is half, and this is 49 over 100, 51 over 100, and the height is 1, and this is the one that's provided to us. Now here we have to draw the amplitude spectra and phase spectra. In order to draw them, we need to find out the frequency domain of this one. Okay, and in the frequency domain, m of t is, this is the one given, and this one has to be found out. The Fourier transform of this one has to be found out to express the whole thing in the frequency domain. So let's go ahead and find the Fourier transform. In frequency domain, triangle of t is, the Fourier transform of triangular of t is sin square of f, and then triangular of 100t, the Fourier transform is 1 over 100 sin square f over 100. Okay, this is the Fourier transform. Okay, so now we have Fourier, and also we have a shift right here. So for the shift we have to use this time shifting property. Time shifting property. So the time shift we have here is 100t minus 50, and if you do the Fourier transform for that, then this is going to be shifted based on like we have to look at t shifted. Like if you want to see what's the real t shifted, then we have to divide both of them by 100. So this is going to be t minus half. 50 over 100, that's half. So is shifted half, so this is going to be e power minus j omega 1 over 2. This one, you know, you can express 50 over 100 to show the shift, but it's the same thing, it's 1 over 2. Okay, and that's the thing has to be done, and other than that others gonna remain the same. So this is an 100 in the denominator, then sin square f over 100. So whenever we have a shift happen, we have to just multiply by negative j omega by whatever the shift happen. If you shift to the right, then this is negative. If you shift to the left, then this is going to be positive on the power. And whatever shift, that's multiplied by j omega. Okay, and that is Fourier transform with that. Now we have to plug it in this equation that is given to us, the signal given to us. Let's do that in the next page. Okay, let's note down the signal given to us, that is phi of t. And so now we have the m of f. Let's note that one down as well. So m of f is e power minus j omega by 2, j omega by 2, and then that one divided by 100 sin square, 100 sin square, and then f over 100. Okay, now the given signal for us is AC m of t cos omega ct plus theta, cos omega ct plus theta. Okay, so this is the given signal. Now here what we have to do is here we can do one thing, that is we can read the cos term. We can express this in Euler's identity like ACM of t, and instead of cos we can put e power j omega c plus theta, ct plus theta, whatever inside the cos function, that's going to be in the power ct plus theta, and plus e power minus j omega c t plus theta, and the whole thing divided by 2. This is equivalent to the cos part of it. Okay, and if you substitute, if you multiply both of them, then we can put a bracket to show it multiplies, both of them multiplies by this. So this one become AC by 2, then m of t, then e power j theta, if we expand this power, then e power j omega ct plus AC over 2, e power minus j theta m of t plus e power minus j omega ct. Okay, and also we had to know the frequency shifting property. Using frequency shifting property, that is x of t times e power j2 phi of t f naught t. So if you have an f naught as the frequency, then when we do the Fourier transform of this is going to be x of f minus f naught. Okay, this is just an example. So similar to that, we can write this one in terms of frequency domain as well. So if we write this is phi of t, and if I write this one phi of f, that's frequency domain. In frequency domain, then this thing is going to be AC e power, only the m of t part we have to careful because we are converting time domain to frequency domain. Other part is just a constant, so this is gonna remain as it is, AC e power j theta divided by 2, and then m part. Now this one has a shift that's based on whatever the frequency we have. Here we have omega c. Omega c we can write it as 2 phi fc. Okay, so fc is the shift happening. So whatever the shift happening, that should be subtracted if it's positive, added if the power is negative. So here this power is positive right here, omega c, so this is going to be minus fc, and this in the other side we have this is negative, so this is going to be exactly the same, but this is going to be added, AC e power okay, and this is j theta, and here minus j theta divided by 2, and then m of f plus fc. Okay, now we have this. Now what we have to do is now we can go ahead and bring our m of f, that is this is our m of f. We can write this one, but wherever we have f, we just have to shift it by fc. That's the only change we have to make. Other than that, it's gonna remain the same. Okay, so let's go ahead and do that. So this is like this, and yeah, so I'm gonna bring it to next page. Let's rewrite this one. AC e power j theta phi of f is AC e power j theta divided by 2, and then after that m of function, that is in our case that is e power j minus j omega by 2, e power minus j omega by 2 divided by 100, and then sin square instead of f we put f minus fc, and then divided by 100. Okay, and same thing the other side, except this e power is going to be negative j theta, and also this is going to be added. F plus fc. Okay, so this is what we derived from the given equation, and to simplify furthermore, you can add these two, like when we e multiply, the powers will add, so you can do that and take the j common. Let's write the simplified form. So phi of f is going to be AC over 2 times 100, that's going to be 200. Hold on a second. So this is 100, 200. Yeah. So this is AC 200 e power j theta and instead of j theta we can write e power j theta minus omega by 2, and then sin square f minus fc over 100, and then plus ac over 200 e power minus j theta plus omega by 2 times sin square f plus fc divided by 100. Okay. So that is the Fourier transform of the equation. So from this one we can go ahead and draw the diagrams. Okay, phase for f is less than 0, approximately phase phi, that is equal to negative theta minus omega by omega by 2 right here. And then so this is line with slope of half, slope of minus half, and then for phase for f is greater than 0, approximately phase phi that is theta minus omega by 2. Okay, and then this one is line with slope negative half as well. And this is theta minus phi over f. Now let's go ahead and draw the spectrum. Okay, since you know that from this the shift is fc and here positive plus fc, so it's going to be centered after fc. So one is negative fc, and the other one is positive fc. Okay, and to find out what's the width, then we had to look at what is it dividing by. So here is dividing by 200. Actually dividing by 100, we have to look at what is frequency dividing by. So that is 100. So this is going to be minus fc minus 100 and minus fc plus 100 over here, and then here minus fc plus 100, and this one is going to be FC minus 100 and FC plus 100 here. Okay, so that's going to be the width, and then this is spectrum, and this one is phi of f, and this one is frequency. And now we are going to draw the phase angle. Phase angle is going to be a straight line, negative line with half slope of half. So it's gonna look like this. And this distance is gonna be negative theta. And this is positive theta, and this is negative theta over phi, and this one is positive theta over phi. Okay, wait a minute, is it theta over phi? Theta minus phi over f, omega by 2. Yeah. Okay, so that is the diagram, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.